अपने अकाउंट को कैसे मैनेज कर सकता हूँ? हाँ, ये चीज़ें हैं, इनको डिलीट करते हैं। हो ही रहा है। ये मेरे को नहीं पता डिलीट कैसे होती है।
ओके भाई, मैंने फाइल बना ली है थोड़ा।
सही है, चेक करो कैसी आ रही है स्ट्रीम या नहीं। हाँ,
और तो मैं छोटा कर दूंगा यार। देखना लिंक पे
दिखाओ। ये नहीं है, यूनिवर्क प्लस HTTP समथिंग लाइक दैट।
यही तो है, तुम्हारी शक्ल नजर आ रही है मुझे।
तो एंड हो गई है ना, इसको छोड़ दो, इग्नोर करो, अभी लाइव आ रही है। अभी अब या so let's start the stream.
लो क्वालिटी माइक अगेन।
So we have two things that we are going to do today. The first thing is going to be my uni assignment, which involves doing some stuff with Git. So Git stuff. Second thing is going to be me going through this course of learn the HTTP protocol in Go. Uh, एक minute. I don't know how to pause. I'm sorry. Just a second. Just a second. So the second thing is gonna be uh, me going through this HTTP course. Now I don't want to do anything too difficult on this team, so I just chose this course, and it's gonna be fun because I don't know Golang, and yeah, this is just me figure. This stream is basically just me figuring out how to go about with this streaming thing. So I guess I shouldn't reveal my classroom. It doesn't matter. What can we do? No one's gonna watch this anyway, so uh, lab 8. Nope. I just want to delete this. Oh, shit. Oh my god. I think I pasted everything here before. Yeah, let's just leave it. Chalo. This thing. Okay. Wow. What is this? Moving on. Okay. Hmm. So I have labtask.pdf. Okay. Code given in above step. So this is the code that has been given to us and to compile your solution. Okay. So I have to use this code and then have to do these tasks on it. Problem statement 1. You are part of a software development team working on a shared fast web application. It's probably the zip file hosted on GitHub. So I have to host it on GitHub. The goal of this task is to help students understand how to work collaboratively using GitHub and multiple branches, and how to identify and resolve merge conflicts, blah blah blah. So first we have to make a remote repository. I think I made one. It was like I'm gonna delete this and make it from scratch. So the reason that I have these partial folders and repositories everywhere is because I started doing this assignment, but then I forgot about it because I had another thing to do, another task. So I think that's it. So instead of reading all the code and stuff from my previous attempt, I thought why not just start it from scratch, because it's a small assignment anyway. Yes. Probably no one's gonna watch this. Let's see. But I wanted to do this for quite some time because if I develop some viewers or something, it'll help me stay consistent and hopefully also improve my communication skills. And it's fun when you have viewers. Not right now. It's just that, uh, I should probably do the next streams from a virtual machine or something. Like anyone can see my files from here. Not that I have anything worth seeing. It's a new folder. Do we have a mb command in PowerShell? Let's just switch over to um, where in w how to navigate to the drive in WSL. Um, oh, so slash mnt slash c. Okay, so I'm gonna use WSL for this because I don't know any Windows commands. It's just easier that way. I'm having a hard time being excited and stuff. 'Cause there isn't anyone here, so cd slash mnt slash c. Okay, okay, we're here. So we have, I think we're gonna move to users, and I what's my name here? Lenovo. You can see that I don't have anything set up. I I recently bought this laptop and it doesn't have uh, its how do you say it? Its BIOS is locked, so I can't. And there's this setting, I don't know what exactly it is, that doesn't allow me to boot from another device like a USB, so I can't install Linux, which was the default operating system for me. Now I'm having a hard time in Windows. CD documents, वॉइस सही है मेरी, आ रही है ना?
बढ़िया।
Okay, okay. Document slash ml something. Okay. Uh, I think I need to put this part somewhere, like this one. I'm not. Let's just leave it. And the new folder. What? Shit. Um, lab 8. Lab 8. So make their PS1 because this is the first problem statement. Where is it? Yeah, PS1. Now I have to make a remote repository and then clone it, and then I'll push code using my clone, the code in the zip file, and then we'll have a quote unquote remote repository with Flask code, and then like I'll make two more clones, which from from whose perspective this lab has been written. So they'll see a shared Flask application, and the first user is just for pushing code and initializing this. So I think I have SSH set up, so I should be able to clone it. IO operation like it on your Windows drives will have poor performance. Okay, okay, that's permission denied. Could not read from the poll. Okay, so I can't clone because I don't know. Permission denied public key could not read from remote repository. Yeah, just shut up. Make sure you have the correct access rights and the repository exists. Ls, aren't we using this? Uh, oh shit, shit. I shouldn't show my key, whatever that was, known hosts on stream. I'll just delete the stream later if I can, or I'll just change whatever this was. Is there an option in OBS to like not show certain things? Uh, display capture, right? So what's this? Um, maybe I should remove this and first I'll add some things. I'll add my browser and yes, okay, and URL. I don't know what shit, shit. I don't want us. Yeah. So I have this thing and I can't can't like edit it or something. Can I switch between my sources? Let's just leave it. Maybe I'll do this git stuff on my own. Let's just focus on the HTTP course. Unless I did start it a little bit, and like uh, I did do some things like reading a file and then making a buffer of 8 bytes and writing into that buffer if we don't have a new line, but we're gonna start this from scratch. uh, but I have some useful stuff in this HTTP from TCP folder. Like I have this test.c. I was looking at how structs look like under the hood, and this is like something that ChatGPT wrote for me. I'm gonna rename this, and what should be its name? Junk? I don't know. Just, I'll just move all my junk here from now onwards. Messing with memory MB, whatever this is. I think I was MB test.c junk the file.cpp. You can see that I'm doing all sorts of things in this scratch file folder, hence the name. And MV coroutines. This is gonna be a topic of another stream. I'm gonna implement coroutines from scratch. It's gonna be fun. RMT make their TCP from TCP, and let's just start the course. I'll do this lab stuff later because I'm having some issues with cloning and stuff. I think I'm gonna start from here. In this course, we'll build our own HTTP 1.1 server from scratch in Go. So I already have Go installed. I did that before stream, and I did a part of this course like up till here, I guess, in Go. Understanding of the Go programming language. If you're fuzzy on that, we have got a course for you. I'm not gonna do that. It's too much effort for like looking at how a for loop works or something. What do they teach in here? Like told you, variables, conditionals, functions. We can look at this from the docs. Channels. We can look at it on our own, but it sounds good for concurrency. Okay. Okay. What binary is? Okay, let's just leave it. We know what binary is. Understanding about HTTP client course. We know about HTTP. I know about HTTP. Understanding the big ideas of HTTP and implement the protocol. RFC is long. So, as far as I know, RFC is a document that documents how different parts of the web work. It standardizes things. I think it's this HTTP 1.1. Yeah, yeah. How long is this? This is very long. Okay, okay. It's an HTML file. We can do something. We can uh, we can curl this guy, and let's see what happens. Okay, okay. Sorry. Uh, curl this guy, and then we're gonna pipe it to wc minus L. Let's see how many number of lines are there. Okay, this is a bad way of doing things, but it's the only way I know how. Like I'm gonna curl it again and again and then five it. I should just download it. Probably has a flag, most likely, for saving it to a file. We can do this. We can redirect the output to a file. So http page.html. Okay. Now we have vim http or vim dot vim. Yeah, we have the http page. WC shit WC http page. So we have, I think this is the number of lines. Okay, this is the number of words probably, and this is the number of characters. Yeah, WC. We have the bytes flag, we have the car flag, we have the lines flag which we used. I want to look at words. Okay, okay. WC minus W http page dot html. So we have, so this is the number of words, this is the number of lines, because I used it somewhere here. Yeah, WC minus L. So lines, words, and this is I think characters. WC minus C http page dot html, and yeah, this is the number of characters. So that's a lot of words. It's probably like equal to a book or something. Like if you have Python, Python 3. So like if you have these many lines and you have like 300 lines on a page, I think that's a good amount. Yeah. So maybe 500 lines. We have 500 lines on a page. Do I have a book here? Uh, Probably have a book on my classroom, since I've already opened it live on stream. I'll just open it again. There's no harm in doing that. I probably have a book in this classroom stream. This is how I normally work. I just distract myself with weird shit when I'm supposed to be working. Uh, let's just go on this page, and I think I have a word counter. Yeah, and this is a small amount of words. Yeah, this page looks good. I'll just copy till here, and I'll just paste this guy. And how many words? Oh my god, how many lines that? Okay, so you have like 1740. Let's just put 1700 as an average number of words. So we have, this is the number of words, and we divided by the 1700. So we'll get the number of pages, 37. Okay, that's not much. Let's try to estimate this from another way. We have lines. No, we don't have lines in here. We can, and keep in mind this is a small number of words compared to a normal book, because you're essentially, uh, you have a big font and a lot of gaps. Normal books don't have this little text. So it's, the RSC is not too big that it can't be read in a reasonable amount of time, but it's too much of an effort when we already have like this course built for us. Okay, RSC is long, it's long, okay, but the main points are clearly straightforward. You will understand from a high level. Maybe we'll read the RSC later if this streaming thing keeps going on. You'll understand from high level what happens when you fetch google.com, okay, to feel like a wizard building the protocol from scratch to gain more challenging programming practice and a deeper understanding of how web application works. So these are the learning goals. Understanding the big ideas of HTTP, okay, I already know this stuff, so but I'm gonna do it anyway. Otherwise we're gonna lose like the point of the stream. We're not gonna have anything to gain more challenging programming practice. Maybe that's worth it to have a good time. Yeah, okay, this makes it worth doing. So because of this, we're gonna continue the story time. I still remember sitting in class fall of 2007 as I forced my first data structure coded in Java, probably a linked list. Yeah, a linked list, and a doubly linked list. The magic I felt seeing a class reference itself. Okay, in that moment I knew I was a computer scientist through and through. I This feeling reached a pinnacle when I had to create a video transfer protocol for a government robot. So video transfer protocol, okay, so wants to transfer videos. Packet reordering, nope. Okay, so it doesn't have packet ordering, like you won't be sending the next packet until the previous packet has been sent properly, or out of order packets would be dropped, I guess. I don't know. Whatever he made. Reliable transport. Actually, yes. Okay. So, okay. Corrupt data regularly. Like, there is nothing right with this protocol. But did I get it? You're done to okay. I felt so. This is actually this actually reminds me of something. Uh, I have an opinion that like post GPT students, most students don't experience these problems because they offload all their thinking to chat GPT, and they make better projects. So if they were being assigned, they were being asked to make a video transfer protocol for a government robot, they would probably make a better robot than what he made, this guy. But but they don't actually learn anything or gain the confidence to build anything substantial without the help of AI. And this matters in case of this matters you're when you're encountered with a problem that not many people have solved. I understand that most people won't encounter problems that haven't been mostly solved already or haven't been explored already on their jobs. But if you want to be valuable, then you're probably going to have to do those things. So to reach the level of doing things that ChatGPT can't solve, you have to go through this process of making uh, half-working things, but by yourself without AI. But that's just my opinion. I'm okay. Let's leave it. I felt empowered, and the best part, it was all in C. Yeah, that's the best part. Well, C is actually I like C. Like you can think. I know there's compiler optimizations and all that stuff, but you have a good model of what's happening under the hood when you're programming in C. Like even if you like reorder instructions, I'm talking about single-threaded programs here. Even multi-threaded. Even if the compiler reorders instructions, uh, you know that the program that the compiler outputted and the program that you think the compiler has made are equivalent from the perspective of execution. Like they're gonna run the same way. So they have, you could say the same logic. So you know what's happening under the hood when you program in C from the perspective of execution. Maybe not 100% accurately from the what's the final binary going to be, but whatever you imagine the binary is going to be is logically equivalent to the binary that actually gets made. But the binary that actually gets made is uh, more optimized, of course. But the security issues, yep, memory leaks probably. I wouldn't know. Yeah, you don't know when your memory is leaking unless you like really monitor your program's execution. Did it successfully, or your program just eats memory over time and this becomes this big bloated mess? Then it takes a lot of RAM, I guess. Did it successfully transfer video while the other team struggled to get basic hardware components to even work? Okay, so this was a competition. Okay. And yep, yes, I felt like a wizard. Yeah, this is a great feeling. This is one of the main reasons I like programming on the side. And I wanted to do that in a community like way. So I started this streaming channel, and among other reasons. And I want you to feel like a wizard too. Welcome to TCP to HTTP. This is a relatively easy course I have done like till there, but I don't want to do the effort of reading this RFC, so I'm gonna follow this guy. Whatever he says, I'm gonna do. We can have fun in our own way. Throughout this course, you'll be using like a problem doesn't have to be difficult for me to have fun programming it. You'll see as time goes on. You'll be using boot. We don't have the boot.dev CLI, and I think it is paid. So I won't install it. I'll just run the code myself. I have Golang, and I'll just test the. I'll see whether it's working as it should be working. So there's this assignment is you have the CLI installed and you're logged in. Copy and paste the run command from the right. So boot dev run, we don't have that. If it's doing what you expect, printing boot dev CLI is ready, then run the submit command. We're not going to do this obviously. So reading all this was a waste of time. The startup. Welcome to the startup. TM. I don't know what TM is. There are few. Actually, I'm gonna check this. TM full form business. TM trademark. Okay, so trademark is something that uniquely identifies a company. Okay. The startup. Okay. So it's a startup called the startup. There are few days in your life more logical than your day at startup. My best day in order have been first day at startup, my wedding day, birth of my first child. So these are two different things. Maybe they see. I don't know. Here the startup, your first task is to build an HTTP server from scratch. A okay, so this is a story around our project, like how his to this is similar to how he wants us to feel like how he was feeling when he was making that video transfer protocol. Okay, that's a good initiative. It shows effort, appreciated. The challenge before you begin startup has to finalize your hiring test. We screen all our newbies by asking them. Maybe he also did this when he was doing that video stuff. He also had a preliminary round. Okay, let's just leave it. We screen all our newbies by asking them to build a much simpler protocol first. We'll start with reading test from a file and bringing it to the console. Okay, okay. So reading test, you might be thinking, how is this a protocol? Um, if you're a Linux user, you would know in Linux, like everything is a file, and even your uh, even from for reading from a pipe. Let me think. Even from reading for reading from things other than files, rockets are kind of files. Yeah, yeah. For input stream of the program and output stream are also files. Like they have file descriptors and stuff. I'll probably have to revise this stuff. Okay. Reading text from a file and printing it to the console. So the file can be anything like and printing it to the console. So the file can be anything like it doesn't have to be a .txt thing. A system call under the hood, you can read pretty much anything. Okay, so assignment, create new exit clear uh, touch messages dot text. Are we supposed to have end here? Let's just leave it. And new main dot go at the root for now. I hope. Okay. So I do a little bit of go tips since I did a few parts of this course before, but I'm still gonna uh, act like I'm doing this for the first time. Touch, so you can see my process of how I approach things I don't know about, how I approach a problem. Okay, so Golang, you can close HTTP and this, you can close this as well. Get started, set docs. So I don't want to go to the Go spec when we already have something easier for us. There was this thing known as Go by example. So I'm gonna use that. Where is it? Uh, I really don't remember where. Maybe it's a tour of Go. No, it's not that. Learn, maybe learn documentation to yeah this Go by example. We can look through the documentation. Like there's a get started hello world exactly what we need. Like just copy this code. So we have a function main. This is easy to understand. We have a import fmt. So we have a package that we're importing fmt.println hello world, and this is the main. We want to export this, so we have a package main thing, and you can see here. Let's just leave this. Um, yeah, declare a main package. Packages to group functions is made up of all the files in and it's made up of all the files in the same directory. Okay, i I don't know exactly what's happening here. Like all the files in the same directory. Like if I have a package main and connecting, I think we're back. Reconnection successful. Okay, okay. Let's just defer this for later. We'll figure out what everything is as time goes on. I'm not gonna read too much of the docs unless I am forced to. Like I'll just copy paste code and go with my own assumptions about what's happening until I have to uh, know what how things are working. Yeah, just I hope I get the job. Okay. So for now it's printing hello world. I'll just replace it. This is just basic stuff. DB. This is a bad way to use Vim, but let's just. I hope I get the job. A better way to do that would be like this D, but I just did delete it word by word. Uh, and then you just, I already know how to run, but it's frustrating. But I'll just go with it. Like go run. So go run dot go. Okay, so go dot mod file not found in current directory. Okay, okay. So we need a go dot mod file, but we can try this. Maybe we can try this because the mod file is obviously gonna just describe how to run the program, and that's only useful in case of multi file or multi-level projects. I'm just gonna go with pain.go. I'm being super pedantic here, but I like this streaming thing is new for me. I don't know what to explain and what not to explain. I'll figure out maybe when I get viewers, actual viewers. Okay, so I ran go run main.go, and it ran the thing, but it didn't generate a binary. Or sorry, it generated a binary, but it deleted it afterwards. So like you have, because Go is a compiled language. This is a bad place to write stuff. It's for drawing, but I'll just try it here. So Go run. What it does, it makes a child process. Okay, so it first compiles. Uh, it runs the compilation in routine in the child process. Makes it uh, runs the binary in a child process. So it's using like a fork command, command, whatever the, and then it deletes the binary. So that's how Go run works under the hood. Maybe later we'll look. Yeah, we don't need it. Like it's a simple CLI program. We don't need to look into how it works. We can, as I showed you, we can like figure out what the program is doing under the hood without having to open up the the program. So go help. Okay, so we have help. This is like obviously. So we have commands like bug, start a bug report, build, clean. So remove object files and cached files, but they didn't get produced. Maybe like go run uses go clean under the hood. It uses go build, and then it uses clean, and clean and build do the things that I showed you. Yeah. What else do we have? We have go doc for package or symbol. So I can go like go doc. We had this uh, we had this FMT package, and we can like go doc FMT less. Shit. I'm gonna pipe it. Yeah. So we have the package FMT, and we don't need to read this. It's a simple printing package, but we know we can use Go Doc from now onwards. Additional help topics, Go help for more information about a command. We can additional help topics. So we have help topics other than these commands, which are these. We can get help for the go.mod file or anything else that we are using or need for our project. Like the concept of modules, their versioning is probably going to be managed by go.mod file, like it's like a package.json. I'm curious to what the uh, how they are like managing this stuff. Like are they using JSON or are they using like YAML or something? I don't know. I really don't know. Maybe you can't, like, maybe this is an indicator that they're using something unique. I don't know. Okay, so we we accidentally made a file named less dot 2j. So this the first part is done. I hope I get the job. Then we remove the printing. Okay, thank God. Uh, then we have, instead your program will need message of txt 8 bytes at a time and print the data back to spread out in 8 byte chunks. So I read into a buffer and I just print it. So I that's simple. We need to know how to get input os.open for reading. So this is a system call, a wrapper over a system call. I need the reference manual. I can't use like go by example. Where is the reference manual? Oh, what's this gopher guides? Let's just leave it. Docs and oh shit, go standard library. Go standard library. It's probably part of the standard library since we're not installing like go install OS, and it shouldn't be like OS is like a basic module. Okay, package OS, package, not module. Overview concurrency. I don't know what they want me to read about concurrency. Package OS provides platform independent interface to operating system functionality. Design is Unix like. Okay, that's why open was familiar. All the error handling is Go like. So in C, when you write like open, you get either like um, a file descriptor or you get like -1. So the return type is int. But here the return type is it can return either error or it can return the file descriptor. So like file comma error. So it returns a tuple and then we are, I don't remember. Maybe it's called destructuring or something. It's we have a destructuring way to destructure things in Go. Let me show you arrays. I'm gonna try to destructure arrays. Oh, I'm wasting time. I know, but okay. This. Uh, what is this? IB? He didn't have an I. Uh, A B C D E equals to B. Maybe it should work. Okay. Here, print of md dot print. What was print line? This is gonna fail, but because it's like FMT. So I think we're gonna need something like this. Okay, we don't have a undefined ARR, undefined blah 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 blah. Too many. So we have to write var. Expecting an expected type. So we have a type here and it's inferring the type. based on the initialization. Okay, so you write the type. Maybe this should work. Oh, five variables but one value. There is probably some spread operator or something. Oh, so 9 and 10. So 9 and 10. And 10 we have something like. Okay, so we can print without formatting with commas like in Python. Unexpected here, dot 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 expected expression. Okay, unexpected. Maybe we can't like destructure arrays. Yeah, he didn't make something like that. But we have some sort of syntax. No, it's not for this purpose. Maybe it is like you have an array literal and you want to expand it into this. I'm being dumb. We slicing functions, multiple return value, variadic. What's variadic functions? Range over runes. We have runes and strings. So runes are something else, and strings are something else. Okay. Coroutines. Defer. Uh, so defer, we're gonna be probably able to write things that we need to do at the end of the function. This is useful in cases where you make like a dynamic array probably, and you want it. It's like a destructor like concept, but for functions. Like you create a file, and so that you don't forget to close it. Like if you have like a big thousand, like 200 lines main function or thousand maybe, and you create a file at the top, and maybe you forget to close that file at the bottom or something, or maybe you accidentally delete a close file or something. So you just write close file very near to the point where you created a file. So if you want to delete this thing, you just delete this thing. If you want to rename this guy, you rename it here. So it's easier, it's better for readability. And why did I open this? Variable function, any number of trailing arguments. Okay, so okay, variadic functions. I don't know exactly how variadic functions work. My assumption for like printf in like the C programming languages, that like printf takes a variable number of arguments after the string that we want to print. So it passes the string, it looks at the string, and it looks for anything starting with this symbol, and then it looks whatever follows it, and it keeps a counter, and not that it keeps a counter, everything until this guy, it writes to the out file, like the file descriptor for the output. And then when it encounters this guy, what does it do? It keeps a point. First of all, it at the beginning of the function it keeps a pointer, and then pointer to the stack, to the current RSP with which the function was called. Maybe it goes from right to left. Yeah, it goes from right to left. And let me think. Hmm. Probably does something like whenever it encounters a thing like this, it goes into the stack, reads the thing that is it is supposed to from the stack, which is described by this guy. Like this is basically saying read an integer from the stack and then print it as a signed integer. Or if you have like something like ZU, this is something that C only C people who have written code in C would understand. If you have something like ZU, I think this is something like read size T, which is 8 bytes for my computer, and then print it as an unsigned number. Or if you have something like uh, P, read 8 bytes in my case from the stack and print it as a hex value because pointers are printed usually printed as hex values and so on. I don't know from where till where does printf read. I'm not sure. I haven't seen a printf implementation, but you can the basic point that I'm trying to make here is that you can infer the number of arguments that you have to read from the stack for printf. Like you can start from the ending of the string in the printf implementation, and you can find all instances of things like this. I think it's called format, I don't know, format converters or something. And once you have that count, say you have a count like 50, so you know you have to read 50 things from the stack. Actually what you can do is while you're reading these things from any direction, like you can go from left to right or right to left, you see what actually they're trying to say. Like if there is nothing before this last guy, you know that we're going to be reading an int which is 4 bytes on my system. And then this basically what I'm trying to say is this is the number of bytes that you're going to read. Okay, first you go through the string, you figure out the number of bytes that I'm going to read. Then you take the current rsp. Okay, okay, I think I figured out how printf works. You have a stack. When you call printf, you have a stack call stack. You have a return address which is one line before below the printf call, and above that uh, you have your registers whose values need to be persist whose values you're storing before going into the function body, so that you can return to your normal execution context after returning from the printf function. If I had any viewers, they and they didn't understand, they could have asked and I would have expanded on things. But now I'm gonna assume you know how the function calling works on the assembly level. And then you have the arguments, which is variable in our case. And first you and I don't remember exactly. I haven't done assembly in a long time, but I think you have the starting point, or at the point you have something stored in a register which tells you like the starting address of the first argument, like where in the stack do the arguments start. I'm gonna assume we have that. And then you have your RSP which points to the top of the stack. So at the bottom of the stack you have the string that you're, I think you push the string into the stack, I'm not sure. I really have forgot a lot about assembly. Let's just assume you have the string or at least a pointer to the string in your stack. I think you have a pointer. I think we have, yes, we have basically a pointer to the string at the bottom. I'm going to write this actually. You have a pointer to string. It doesn't matter whether the string is has been written into the program at compile time or we're getting it from the user at runtime. If we're getting it from the user at runtime, we're basically be gonna be making a string using a buffer using malloc and store things into that. And when we call a function, we're gonna pass a pointer to the string into the function call. And if we have like initialized that string into our program like a hard-coded string, it's gonna be probably stored in some way into the in the program, and we can point to that obviously. As far as I remember, in C and of course in assembly, you pass a pointer to a string. You don't pass a string into a function. So we have a constant sign, a size pointer to a string. You get the pointer to the string to the first argument in printf using this guy, and then you go over that string. You iterate over that string, and before that you store this the current value of RSP. The first thing you do when you get into printf is you store the current value of RSP in some place in a register or something, because that's going to be useful later on, because in within the function we're going to make our local variables, and we don't want to lose the location of the top argument. So we're going to store this guy, and then you store this guy, then you make a variable. So you make a variable and count. You make a variable, it's an, let's suppose it's an integer, or you can make a size t. You have a variable named count, and you basically get the count of bytes. You can do that in a naive way by going over the uh, going over the string, or you can just subtract these two guys, and do some sort of arithmetic, and you can, like, you subtract these two guys and you subtract the size of the pointer, and then you get the count of bytes, uh, of the variadic arguments, like the variable number of arguments, like the things in printf after printf, like this is the string comma space a b. So you get the number of bytes of these guys by subtracting these two and subtracting the size of the pointer. Then you go from left to right in the string, and whatever things are before this symbol, you just write them to std out. Okay, the std out file number. A process has file descriptors of its uh, of the files that it has open, and by default it has it has a file descriptor table, and you have like file descriptor values for std out, etc. You write this stuff to std out using a system call, and after that maybe we're going to implement printf in the next stream. It's going to be fun. And then when you encounter this guy, you read what's beyond this. You have some passing logic, and what based on this guy, if you have like you can check out the man page for printf if you don't know what these things are. You read as a long unsigned int, and you print it as unsigned, if I remember correctly. So based on this, you go to let me think, do we even need count? I'm not sure if we need count. Let's just leave it for now. You go at size of pointer minus this guy, whatever in whatever register this guy is stored. So you go here and minus okay, so count is going to be initially 0. Okay, it's the number of bytes that we have read from the stack from this point onwards. So it's the offset from this point onwards. So you have a b. So if this value is 0, it means that I have not moved, uh, I haven't read anything above this line. If it is 4, it means I have read 4 bytes above this line. So this line we always have, and we have an offset. So we have a base and we have an offset. Base is actually equal to this guy minus the size of pointer. Okay, so you have offset 0. When I encounter this guy, based on the logic that has been written here, I read a specific number of bytes from the stack and put it into a variable or a register, and then I increment this guy by the number of bytes I have read. In case of ZU, I read 8 bytes, and then I put 8 here. I read 8 bytes, and then what I'm going to do based on my logic, like I have here unsigned int. So I'm going to write an unsigned, I'm going to convert this guy, I'm going to convert whatever I read from the stack, and I'm going to convert it into the form that I want. And then I'm going to write it to std out using the write system call. On the, I think it's 0 in the file descriptor table, the std out. It doesn't matter. Let's move on. And then I have 8 bytes. Then when I encounter a next, then I actually just write whatever uh, things without this guy, this escaping character. I write all of this to std out, and then when I encounter this guy again, I pass it. I have my custom passing logic. Based on that, I read from the stack. I read from the stack based on this base and this offset, and this parsing logic, like how many bytes do I have to read. In this case, I don't have to read, I read more than 4 bytes. I read 4 bytes, and then I convert them to a signed integer, and then I write it to std out. That's basically how printf works. That's the purpose of all of this discussion, was to demonstrate how variable number of arguments work, at least in case of printf. Now, I don't know how in general do variable number of arguments are handled. I guess it's based on the logic that you have for the function. But since Go provides, let me think, let me think. Like if I made a function with a variable number of arguments in Go, not in C with inline assembly or something, in Go, how does the Go compiler handle this? How does the Go compiler convert this? I don't know. Maybe there's a way to generalize this whole process that I just described to you, but I don't want to use too much of my brain power. It's obviously, yeah, it's pretty, I have an intuition that it's pretty easy to generalize this whole thing that I just described to you. But I don't want to do that right now. Maybe I'll make my own programming language, and in that process, I'll just explain what's happening, what's going on. But for now, let's just leave it. I have let's just leave it with both me and the viewer have a pretty good idea of how a very variadic number of arguments works under the hood in assembly, at the assembly level, at least in the case of printf. And we have a feeling that it's gonna be pretty much the same for pretty much similar when we're making a generalized version of variadic arguments. It's pretty easy. Like we're probably gonna have some, yeah, it actually is pretty easy. Let me show you. Like when you have this variable number of arguments, you actually specify what the type of that is gonna be. So when I am iterating over nums, I know that I have to just keep on going. When I'm asked for the next value in nums, I know that I just have to go 4 bytes above and read the next value until I reach the base value that I have stored. I store the RSP at the start of the function, and I keep I keep on going reading this variable. What's happening, man? I keep on reading this stuff from the stack until I reach the space value. That's when I know that nums is over. So it's pretty simple to implement variadic number of arguments in a function in a programming language. Okay, that's easy. Okay, okay. Let's just move on. Where were we? Okay, this is what you guys are gonna have to deal with if there are any viewers. If you whenever I'm doing an easy project, I just uh, start to think beyond the scope of the project. So you're gonna have to bear with this. Okay, so read 8 bytes from the file into a slice of bytes. So we have a slice, the concept of a slice in Go. We don't need the reference. We can look at this from Go by example. So we have arrays and we have slices. So I'm going to read both of them. I need to know whether arrays in Go are dynamic or are they static like in C. And I need to know how to use the stack and the heap in Go. Okay, so arrays, and in Go an array is a number. Just give me a second. In Go, an array is a numbered sequence of elements of a specific length. In typical Go code, slices are much more common. Arrays are useful in some special scenarios. Okay, so an array is a numbered sequence of elements, so it is numbered. So we know the number of elements beforehand. I'm being pedantic. I'm reading too much into it. I should just read this the thing as a whole before making any assumptions. In typical Go, slices are much more common. Arrays are useful in some special scenarios. Okay, so arrays are not very common. Here we create an array A. Okay, we create an array A. You have a var keyword for declaration A5 int. So we specify the size, and then after that we specify the type. It's a cool looking syntax. It's looking funky. Let's just leave it for now. Okay, so uh, that holds exactly 5 ints. The type of elements and length are both part of the array's type. This is interesting. So basically what he's saying is, maybe I'm reading too much into it again, but what he's saying is, he or she, whoever wrote it, var a, if you have an array var a 5 int and you have an array b 7 int, these two are not equal. The types of these two are not the same. This is a different type and this is a different type. What it means is, you can't assign a to b or b to a. What it looks like under the hood is, let me think. So basically array is not, so when you write var a5 int, you're making this on the stack. That's basically what this all means. Yeah, nothing more than that. Okay, because only then you can't assign a to b. If you had like something on the heap, for example, if you had like under the hood, Go was using like void pointer, or yeah, void pointer a and void pointer no, like int a and int b, then you could assign a to b or b to a. Or even if you had like a struct type def struct, and you had like int size t size. I need to do this in an editor, but I don't know when I'm doing it here. Capacity and I had here hmm, int. Let's just do four ints right now. Int ARR, and I think we have commas here. I don't remember. Let's just go with commas for now. And I had um, integer ARR. Okay, and then if I assigned, and if when we used var a, we actually made ARR a. If we made this stuff on the heap, then we would be able to assign. But if we made it on the stack, we would have to write custom logic for that. Yeah, both are possible. In both cases, uh, in both cases, assignment of var A to var B would have been possible. But since it is not possible, I don't know what they're doing. Honestly, maybe it's a scale issue. Yeah, it's a scale issue from my side. I don't know what they're doing under the hood. But anyways, let me finish my making my point. Like if you had var a 5 int and var b 5 int was implemented at this as this guy, like this guy, it was a simple pointer to pointer assignment. And if you had like this guy implemented as like this, uh, you would just have to write a function named a function for whenever you encountered an equal in the uh, pos tree, you would just write a custom equalization logic. You would maybe delete the, maybe you keep a ref count. I don't know. Go is garbage collected, right? So this guy would have a ref count or something. Ref count would be decremented, and then uh, yeah, for A the ref count would be decremented, and then for B the actually I need to look into how a real programming language is implemented. I have some experience in implementing a toy language, and that too not fully. So I have some intuition of how things are going on, but I don't know fully. I want to know fully. Maybe I'll do it in another scene. Anyways, why there's still data in there? We are spending too much time on this simple program, but I'm having fun. I'm learning. I hope the viewer, whoever it is, if any, is also learning. While there is still data in the file, read 8 bytes from the file into a slice of bytes. Yeah, we were looking at slices. So first we'll clear out what arrays are, because arrays were before slices in Go by example, and these two concepts are related. So I don't want to mess up my I don't want to have trouble understanding slices. So that's why I'm reading arrays before that. Okay. Go by example arrays. Yeah, number of sequence of arrays we have already read this. Here we get an array 8 that will hold exactly 5 ints. The type of elements and length are both part of the array's type. By default an array is 0 valued, so it declares the array and initializes it with zeros. Maybe for the compiler thing that I want to build, maybe I'll just make a compiler for this Go language, because I don't know much about programming language design, so I'll just probably have to use someone else's design for when I'm building out my compiler. Maybe after I build my compiler and have had much more experience in programming, will I think about programming language design and stuff. Maybe then I'll also have a clear idea of what use case do I want to build my language for. Even if It's just for pedagogical. I think pedagogical. I know.
pedagogical,
Okay,
pedagogical,
Okay, pedagogical. Okay, maybe even if it's only for pedagogical purposes, I want to make a good programming language that I can use in my hobby projects and stuff. At least for my hobby projects, maybe I'll try to make it popular in the market. Okay, so here we create an array, 5 ints. We already know this. The type of elements and the length are both part of the arrays type. You can just, even if it's implemented like this, you can just like not implement the equality operator, and it would just work. This statement would still be true, like this statement. You just don't implement the equality operator, and you have the, and then you have this functionality of the type being uniquely identified by the size of the array. Okay, for by default an array is zero valued, which for ints means 0s. I don't know what this is. 0s. That's the first time I've seen this. Zeros. Oh shit. Zeros. I don't know what to say. Like multiple zeros. The multiplicity of zero can be written as zeros or zero or zeros. I'm actually kind of dumb. Okay, okay, okay. We can set a value at an index using the array index, obviously. Okay, and get that value. If it were not this, I would have been super angry. Like, why won't you adopt the most intuitive syntax of all time? Okay, the most ubiquitous syntax for arrays. That's a better word. The built-in length returns the length of an array. Obviously, even C has this. Uh, I think it's yeah. It'll be compile time because these arrays are declared on the stack. At least they, yeah. And also, I don't understand why would you use like int pointer arr. I forgot why I made all this thing in the first place, but I don't think you would use arr for static arrays. You would just declare it on the stack. This is a dumb assumption. But I was being permissive. Like I was saying, even in the worst case, uh, no. I don't. I actually remember why I was doing this. I was doing it to justify how uh, assigning arrays to each other is an easy thing. Yeah, that's what I was doing. I was making an easy implementation of assignment of arrays, and it is not possible to assign arrays if they are declared on the stack. So if they are not declared on the stack, and if uh, you have a fixed size, what am I saying, man? If they are declared on the stack and they cannot be assigned, wait a minute. Arrays can't be assigned to each other. They have a fixed size. Therefore, there is no need of this crap. So we can safely assume that if the designers of Go are assuming no other complexity in the implementation of Go other than just the use case, we can safely assume that arrays in Go are actually stack arrays under the hood. I'm wasting so much time. The built-in length function, it uses syntax to declare and initialize array in one line. Okay. This is interesting. So you can assign. You have this assignment thing, and you have this thing. You have a literal, and then you have a size and type, and you can also do this. You can also highlight the compiler count. Yeah, this is obvious, but this is interesting. and I what's this, man? B has already been declared and initialized. Now we are assigning this to B. Oh, okay, okay. Since this literal has size 5 and B has size 5, so you can assign arrays of equal size to each other, just like you can assign stack arrays of equal size to each other by just looping over the elements. Okay, okay. This is simple. If you specify with the amount of depth I am reading this the Go spec, I should probably just learn Go fully. Maybe I'll commit myself to learning. Maybe because I already have a bunch of languages which I know a decent amount of, but I don't know enough to get a job, get a good job. Okay, let's just. I want to stick with one language and uh, master it, but then I also want to do these sort of things. I also want to have fun. We'll figure out. There's also the thing of the main thing is not to learn programming languages, even though you need to master at least one, in my opinion. Main thing is to solve problems. This is just scope. Okay, let's get back to it. Yeah, the compiler count for element number of elements for you, blah. If you specify the index with colon, the elements in between will be zeroed. So I actually tested this. I remember testing this. Uh, Testing something about this. Okay, so b equal, you have this thing, compiler will infer the number of elements, b is being assigned, so this guy, this literal should be of size 5. It must be. You have 1 size equal 1, size equal 2, and 3 colon 400. So if you specify the index, so we're specifying the index for this guy with 3 colon 400. So at index 3 I want 400. Okay, so you have an array of size 4, and this is a bad way to, I should do this in the editor. You have a size 4 array, you have a size 5 array, and you want to assign to it this guy. Where is it? This guy, 100, 3, 500. So 500. Oh, let me make it more clear. Equals, I want to assign to it this guy. You have 100, at the end we have 500. The type of this guy must be equal to this guy, and since we are letting the compiler infer the type of this guy by not let me think. Yeah, we're letting the compiler infer the size of this guy, so we're partially letting infer the type, so it must be of size 5 since we're letting the compiler do it, so it must be of size 5. So we have this size 5. I forgot this is not Vim. We have this size 5 array, and we also specify the number of elements here: 100, 500, and at index 3 we want 400. So we want, at the end we want 500, at index 3 we want 400, and we want 100 here. So that's what we are doing. Yeah, if you specify the index with colon, if you specify the index, the elements in between will be zeros, and we will only have elements in between in case of an assignment because the type of b has already been determined. So if b has size 100 and I do this colon syntax thing, everything other than this colon guy will get zeros. Everything other than this colon guy and this guy will get zeros. That's simple. And I wonder what would happen if I put 2 here. Like, does this colon thing have to be adjacent to the last um, positionally assigned value? I'm calling this positionally assigned and because this is like based on key. This is assignment based on key and this is like based on position. Yeah. I wonder what would happen. Let's just waste more time. Touch time waste dot go vim time waste dot go package main import fmt func main. So that sounds new, and because of the novelty it sounds good. It just looks cool. Func. Okay. B is this guy, and then let's just copy paste because we have already wasted enough time. Ah, I have B, which I am declaring and is initializing at the same time with an array of size 5. I wonder what would happen if I remove this. Go run time waste dot go. Okay, syntax error, unexpected name at the end of statement. At line 8. It was at line 8. Uh, the reason I have a minimal vim config and I have to write set number again and again is so that I don't develop the habit of continuously adding to my config over time and hence become unable to use the base version of vim. And the reason I want to be able to use the base version of vim is for portability. So I want to be able to go on any computer, just install vim and just start working. This is useless, that's why we're probably getting compiler error on line 8. This is also not needed for, maybe we can comment it out. uh, Clear go run main.go unexpected expression line 9 and line 10. Unexpected triple dot expected expression. Okay. And syntax error unexpected bracket at end of statement. Unexpected bracket at end of statement. What's the problem here? Oh, I'm running the main program. Okay. Go run time waste. I want to run the time waste. Type is not an expression. 6 7. GG5J, and we have this guy. 7L at 7. Time waste. 5 in type is not an expression. At 6 7 I can't find anything like that. I did jump to the 7th byte, the 7th character. It's not an expression. It's not an expression. Where am I making it an expression? Oh, why do I always open main.go? Maybe that was the problem. 5J 6L. Okay. Oh, okay. So whenever I am initializing, there's two separate things. If I'm doing var b 5 int, then I don't need to specify the elements. But when I'm doing the initialization and declaration syntax, I need to give a literal at the end of this guy. 1 2 3 4 5. Okay. Okay. Now, what I wanted to do was this 2 3, and I want to see whether the index, what will happen to index 3 and whether or not it will compile. I'm I'm wasting so much time on basic stuff. Okay, this is interesting. So 0, 1, 2, 0, these were positionally assigned, and this guy was based on keyword, and this guy and after the positional thing after the keyword guy was the element after the keyword. So it wasn't like we're going we have like two extremes, anything to the right of a keyword thing, keyword value, keyword assignment is like the last element from the right. It isn't like that. I also want to remove 2 from here. I want to remove, oh, I want to remove this guy. Go run time waste. Okay, so anything that is not, if my array, my literal contains colon, it contains any keyword thing, keyword value, anything that hasn't been specified will become the, oh, this is kind of obvious, I didn't need to do this. Okay, let's just rm time, it really was a time waste. Okay, okay. Slices. We have yet to get to slices. Okay. Colon and elements in between will be zeroed. Arrays are one dimensional. You can compose types to build multi-dimensional data structure. We don't want multi-dimensional arrays, but it is good to know. You can create and initialize multi-dimensional arrays at once. You can also initialize them. You have this literal syntax. Okay, and we can also do the keyword thing in literal syntax. Note that arrays appear in the form blah 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 when printed it. Okay. Okay, so this is the standard form of printing arrays. It's pretty cool. You don't have to do overshit. Next example, slices. We will remove this guy. We'll go there. We'll just, okay. Slices are an important data type in Go, giving a more power. This is a really basic overview of Go. But what can I do? I don't know how Go works, and I want to take my time. So if anyone doesn't want to watch, they can just go to another stream where I'm working with a language that I'm familiar with. Yeah. Unlike arrays, so if anyone is frustrated by the amount of basic stuff that I'm doing, they can go to another stream of mine once it's recorded where I'm actually working with a language that I know how to work with. That would be in where there I'll be solving problems, actual problems. Maybe my next stream will be printf implementation. I pretty much now understand how printf has been implemented. It'll be fun. I'll it'll have inline assembly and stuff. It'll be cool. I don't know how to do inline assembly. That would be fun. Okay, and it's just cool to know like I know how standard library is implemented and see. It's not much. We just saw the logic of printf. It's not that much difficult, but it's significant. Like if you don't have you don't know how the stack works, how assembly works, you're gonna have a hard time understanding how printf got implemented. But if you have the domain knowledge, it's pretty much a simple function. But I want to implement it just to show that I can to myself and to others. Size is an important data type in Go, giving a more powerful interface to sequences than arrays. Thank God. We have to import slices. When we are importing FMT and using FMT, we have this FMT dot syntax. So let's see where we have slices dot. Slices dot is used at only one place. When you're comparing slices. So everything other than that is just basic core syntax that you can use without slices. Unlike arrays, so slices are built in because we are making a slice here to create a slice. We're creating a slice and make is also okay. Unlike arrays, slices are typed only by the elements they contain, not the number of elements. I really need to figure out what I should explicitly say and what I shouldn't because I'm talking too much. Like some things are obvious. Let's just leave it. Let's just I'll just let myself be natural. If I want to say a lot of things, I'll just say them. Unlike arrays, slices are typed only by the elements they contain, not the number of elements. An unlisted slice equals nil. I'll stop the stream probably in like 15 minutes because I have to go. I have something to do. Unlike maybe I'll start streaming again after I come back. I have a short task to do. I have to pray. Unlike arrays, slices are typed only by the elements they contain, not the number of only by the elements they contain. Yeah, so it's like a pointer to an array, but you also have fancy things like maybe you have bound checking. So you have an append. So you have a wrapper over the controlling the. You have a wrapper of over the pointer or over the append function. Maybe they won't provide us direct access to pointers. I haven't seen pointers yet. Maybe make gives something some sort of pointer or a reference to an element on the heap. But as we saw, the s variable for the slice can be made on the stack and the underlying type can manage things on the heap. We'll just see. We'll just see. Unlike arrays, slices are typed only by the elements they contain or the number of elements, and slice equals to nil and has length 0. Okay, so there is nil type in Go and uninitialized slice equals nil. So obviously we're going to have some sort of size, some sort of um, we're going to have like a struct or a struct slice under the hood, and that's going to be put on the stack obviously, and the dynamic array is going to be on the heap, and we're going to have a pointer within the struct. So and we also have some sort of weird abstraction where nil can be equal to an uninitialized slice. That is a slice where its items or its array is equal to null ptr. It's a null pointer. Okay, they have some custom logic underneath. I will probably make a compiler that compiles Go because I also don't know how garbage collection works. That would be fun to implement. It'll probably involve some smart pointers or something, and I'll do it in C because I also want to implement like this smart pointer stuff myself. I don't know. I really don't know. I'm just guessing, but I want to make this compiler. Maybe I'll do a few more projects and Go. Maybe I'll yeah. If Go supports, no, I don't think it supports inline assembly because it's like a high level language. Unlike arrays, slices are typed only by elements they contain, blah blah blah. Slice with non-zero length, use a built-in make. So here we make the slice of strings of length 3, usually initially 0 valued. Um, make, okay, so we use the make keyword. Slice with non-zero length. But what if I want to make a slice with 0 length? So I just use like var. Maybe I'll make this guy and I'll no. We want a 8 byte buffer. So we want 8 bytes. And what is this guy doing? He's saying read 8 bytes from the file into a slice of bytes. So he wants me to make a slice of bytes and he wants me to read 8 bytes. So 2J, as far as I know, in the OS package, I actually remember this. Like os.openfile.go. Okay, we open the file. We make. Okay, he's making 100 bytes array. We don't need that. Sorry, this is the Go docs. I'll make an 8 size, 8 bytes array and work with that. I want to see. Let's just leave it. Let's just work with slices. I don't want to know whether or not OS open can be used with slices, with arrays instead of slices. Oh, sorry, not os.open, file.read. So we have main.go. Is this main.go? Okay, this is main.go. So I want to delete all of this. I want to open a file. Where is the I want to open a file. uh, I want to open a file and I want to read it and go run. I want to see error messages. So I won't enter the correct file name, which is messages.txt. Run main.go. This is not the me at my fastest. I am just taking a long amount of time on purpose. It's just fun, more fun that way. Like I'm exploring as much as I want to. Like it's not an assignment or a thing I'm doing on the job. I'm not going to be exploring this much on the job if someone gives me a task while I'm working, or if I have a university assignment and my deadline is near. But this is just me doing a project on my own accord, so I can take as much time as I need. I don't need to finish this in like I don't need to speed run this project. So command line arguments. I don't know why this thing appears again and again. I really don't know what they thought while doing that. Main.go 3.8 FMD imported and not used. Oh, so this is also an error or a warning. They should specify if this is a warning. Maybe if they didn't tell us, then it's an error. Declared and not used file. Okay. Undefined OS, undefined log. Okay. Uh, uh, and log. FFD ported and not used, and so this is an error. It's not a warning. No, 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 no. Maybe I should printf fmt dot print ln. Here's another interesting thing. Anything that all the functions that I'm using have start with the capital letter, but main doesn't start with capital. Maybe it's reserved for like model functions, I guess. fmd.println. This is running. I don't need bash n because it's a print line. Go run main.go and declared but not used file. So it didn't print, which means that this is a compile error. It's not a runtime error. Maybe Go has some flags where you can like disable this declared and not used error. Like you just want to allow unused variables. Maybe. Now the file has um, print. Let's just print fmt dot print print ln file, and let's just leave it like that. And we have used fmt os and log. Go run main.go. Here's the file error. Open file.go, no such file directory. It's a simple error. Exit status 1. Okay. We're seeing some hints of C and stuff. In the errors. I want to no now you and D4B maybe, yeah, that will work. It's not a file.go, it's messages dot text and go run main.go. So we got the file descriptor, I guess. Yeah. So file successfully opened, and now I want to uh, file data can be read into a slice of bytes. So it can only be read into a slice of bytes and not. Okay, read and write take the byte counts from the length of the argument slice. Length of the argument slice. But arrays also have the length of arrays can also be taken. So maybe read and write can also use arrays instead of slices. Maybe. Let's just test it. Ah, okay. So we read this many bytes and go run main.go. Yeah, we read 100 bytes and it's not enough. Now we need to I'll just replace this guy data var. So okay, so you can't declare and initialize arrays, I guess, because you need to specify fixed size, or maybe you specify the size, then you the arrays can colon equal. Okay, arrays can use the colon equal syntax, but you'll have to specify a little, which I don't want to do. So I'll just use this var guy, var data byte, and I'll use 100 again. Go run main.go. Cannot use data. Okay, so I think it's attempting to cast and failing. It looks like from the way it's phrased, it looks like Go supports implicit casting. It tried and then it failed. No, 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 no. Actually, I'm wrong. If it had supported casting, maybe. Let me go build. Let's see whether it builds. Oh shit, 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 shit. Okay, so it didn't build. So uh, Go supports implicit casting. Maybe that's unknown, but whatever the case, it tried to cast at compile time, which I think casting does occur at compile time only, at least in case of C. I don't remember. I'm a noob at C. I'll I'll learn as time goes on. Uh, let's just ask Chat GPT. I shouldn't open this. I should open it in private so that my chats. I don't have useless chats in my chat history. Uh, does type casting in C work at compile time? Let's just see. The answer depends on the cast and context. In many cases, typecasting is a compile time operation. For simple typecast, you have int x equal 10, float y equal. This is like this can be resolved. So if you have the value, then you can resolve it at compile time. Okay, okay. These are static casts, yes. However, typecasting does not always result in compile time change of representation or behavior. Instead, example pointer casts. So the logic of the casting can be inferred at compile time. Like if you have like I don't know, maybe you have, if you have like a int and you're taking it from the user input, you're not taking it from like somewhere else, and you're not you don't have like this hard coded value. You're taking it from the user input, and then you just if you have and you cast it to a float, the compiler will check whether it can be cast to a float, I think, and will throw an error if it cannot at compile time. And if you have like so it will throw an error in case like I think floats can't be cast into ints in C, I think. Let's just check that as well, and then I'll have a break. I need to go pray. Touch test.c, vim test.c. So stdio.h int main. It'll probably be like a half an hour break. It's too long. Maybe I should just stop the stream and make another one. Let's just leave it for later. Uh, I don't need it anyways. Int x. I think scanf is a function. I have forgotten C. Float. How do you take in floats? Man printf.3. Oh shit. Man scanf.3. What am I doing, man? Uh, Conversion. So yeah, it's similar to printf. Okay, the conversion stuff. So you have this guy. Conversion specifiers are available. Okay, so I need to see where I have assigned. Yeah, matches an optionally signed floating point number. I think F. I think I'll use F. I think it's F. I don't remember. We'll just see what happens. Oh, and int y equals int x. Ah, uh, int y equals float x return 0. Okay, it did compile. Okay, so I made a mistake. I'm actually trying to write um, recover. So I have this file. I there was some issue with swap files in Vim, and I didn't want to. Oh shit! इसको चुप करें. Okay, so you have a compilation error. Okay, so I was right. Okay, I'll stop streaming for now, and I'll maybe just um I don't know what to do. I'll stop streaming. Yeah.